match my words to my actions. Magic in my life's everlasting. I say I could have the world or be with any girl, but something about your style makes me wanna man up. We should fill our cups, catch a flick and do some stuff. I'm used to one night stands, but with you that's not enough. I don't wanna front, I just wanna see ya. Please give me a sign, yeah. Please give me a sign if you wanna come. Please give me a sign, yeah. I don't wanna front, I just wanna see you. Please give me a sign if you wanna come. Why you presenting games I don't wanna play? I've been on my grind, I just wanna lay down with you. Spark a doobie, hit the town with you. Life is complicated, but I found in you something simple, I can wrap my head around it. Be my lady, cause you keep on around it. You see all the women in my DMs, it's astounding. You ain't gotta worry about a thing, you got me grounded. Yeah, I say any truth that I wanna say. Let's appreciate our youth like it's our final days. I'm the rarest in the deck, call me ace of spades. Life is anything you choose, and I would choose you, baby. I don't wanna front, I just wanna see ya. Please give me a sign, yeah. Please give me a sign if you wanna come. Please give me a sign, yeah. I don't wanna front, I just wanna see you. Please give me a sign if you wanna come. I don't wanna front, I just wanna see you. Please give me a sign if you wanna come through, through, through. Oh yeah.
Hello. All right, I am back with another stream. We're going to continue where we left off with the last one. I was working on, switch over to the actual display. I was working on this Boston Key Party 2016 Simple Calc challenge, and after basically giving up thinking that I couldn't think of any way to solve it based on what I thought were the techniques I was supposed to be using for this set of challenges, I started walking through the README, or the walkthrough rather, at the end of the last. I'm going to turn off the audio. I think y'all can't hear it. Well, I probably haven't. I did turn it down, so y'all can't hear it, but I can still hear it. Yeah, so I was going through the walkthrough, and I got to a point where they said, okay, this has to be solved with ROP chain. And since I hadn't considered that in scope, as it were, for my techniques that I could try, I stopped reading the walkthrough, and I'm going to attempt to solve this by sending in a ROP chain that will be my shellcode to call the exec VE syscall and pop a shell. I've not ever done a ROP kind of thing before. So at the end of the last stream, I mentioned I was going to just try to learn a little bit about that before coming back, and I have read up on it somewhat. I think it should be doable to, or it definitely is doable, to accomplish this with the ROP related tools that are already in the Pwn Tools library. There's a ROP module in there, and I think I understand it enough to know what I need to do with it. And I'm going to try to do this as much manually as possible so that I get some practice with the details of how it should work. I don't think that adding some tools on top of stuff is necessarily would like distance me so much from what's happening that I would not be learning. But this one should be relatively simple, and I'd like to kind of walk through it, as much by hand as possible. I'm not gonna like write my own gadget searching program because that doesn't seem like it's going to be useful in this particular context. I think that would be a fun thing to do later on, especially because I do plan on working on like a x86 decoder kind of project just for like making sure that I really understand that kind of stuff. For me, at least, I find that if I program something that helps me, if I build something with code that helps me understand the details of it a lot more than just reading documentation or reading a blog post about it or something. So eventually I want to write a x86 decoder, and if we've got that, then we could probably do a ROP gadget kind of finder, at least a simple one that just takes a binary, looks at what segments are executable, and then works through all of the bytes in those segments looking for gadgets. Because you don't need a full disassembler level analysis where you try to determine which bytes really represent instructions or not, since you could jump to any byte on x86. You don't have to worry about whether or not things really were intended to be instructions as the compiler output them. So just having the decoder should probably be enough, but there's a lot of details in there that I'm sort of glossing over. But for now, I'm going to use the built-in gadget finder. I'm going to come up with a array, or not an array, but like I'm going to come up with a plan for what exact instructions I want from my shellcode, because I think I'm going to not try to just manually convert the shellcraft generated shellcode. I'm going to do a slightly simpler one, and obviously I'm going to use techniques that wouldn't be in those shellcode. So because I can write stuff that will just show up directly on the stack and then pop those from the stack already into certain registers, I don't have to worry about some of the stuff that's in the shellcode, which is like pushing stuff onto the stack, pushing stack literals to represent the string for the binary that I'm going to run the shell command. So it's going to be a little bit different than what the shellcraft assembly code does, and hopefully a little bit simpler. Harp 6X, yeah. ROP Emporium seems really good. I have it here in my list of stuff, I think. My list of tabs that I've been going through. I decided to sort of set that one aside because I want to at least solve this challenge that I'm looking at right now, and then come back to work on ROP Emporium. I don't know when I will get to it, but I was thinking going through these nightmare challenges, unless all the ones following this start requiring me to use ROP. If they don't, then I'll just keep going through until we get to like section 7, chapter 7, whatever, which it's all about ROP. And then, it'll probably be a little bit better of a time to switch over and do a bunch of stuff from ROP Emporium, where ideally it's a bit more, I don't know. I haven't looked through what they have in the list of challenges, so I don't know to what extent this stuff is organized in a particular order of use a simple technique to solve this one and then use a slightly more advanced kind of technique as you go through. Clearly there's more to it than I think I even understand right now, not understand the things, but understand the scope of the things. There's probably a bigger scope to what you can do with ROP, or how you might have to go about writing ROP chains in very difficult scenarios, I guess. Presumably there are binaries where it's possible to do it, but you need to really do it in some super particular way to get it, and I assume that's why there's so many challenges on this site. That's just download all of them. Maybe this is the total of them. It's about 8. But yeah, it should be a good idea to go through all of these. And yeah, so I think I'll get to that at some point, but thank you for the suggestion, because it seems like a good site. I ran into it earlier in the videos that I'm doing as I go through the nightmare challenges, because they had some FAQ page. Oh no, it's right here in the guide, the common pitfalls. This particular pitfall actually hit me just when doing a shellcode with not needing ROP, just put it directly on the shell and execute that. Put it directly on the stack and execute it. So they had the NX bit was off. I was running into this because I'm doing stuff in a Ubuntu 18.04 virtual machine, and that was my first exposure to this might be a neat website. And I'm sure that all the guide stuff, I might come back to this just in this video if I'm having a lot of trouble getting the intended ROP chain for this challenge to work. I might just go through the guide and see if it has advice that I need. But I feel like I have a sense of what I want to do at this point, so I'm gonna just try to get started with that. Yeah, so so much of this stuff is no longer relevant because I'm not actually trying to write some shell code. I'm not gonna probably put it into assembly. I'm going to have I'm going to open a file. I don't know, I'm going to call it ropcode.asm or something, because I want to use this to plan out what gadgets I'm going to search for and use. and then we will do, I think it's like ROP gadget, maybe it's what are the available commands? I thought there was, interesting, maybe they have switched it around in more recent versions, but there had definitely been a command line tool for searching for gadgets that I saw in some guide that I'll have to, I don't know, look for again. But for, yeah, oh, it's capital ROP, maybe? Okay, there we go. I do have ROP gadget from here. So I should be able to say like ROP gadget, symbol calc, and I just say, tell it that binary, and then it will search through, find potentially a bunch. I would assume these jumps, maybe they, I don't know why we're getting ones that end with a jump. I guess there's jump oriented programming as well. And really, I don't know enough about jump oriented programming. It feels like that would be harder to work out manually, because then I have to follow those jumps and know what they're doing as well at whatever the target is. And unless that's a jump to a thing that then jumps to a certain uses a register, like an indirect jump, or whatever the target of this does a ret, I don't know. So how do I tell it just no jop, I guess? Okay, let's see if that works. Okay, so these are more in line with what I've been thinking about. So we will look through this list. I'll probably just, why don't I'll just put that in a file, and then we can grep that file. We don't have to keep searching through the binary every time. So what I need to do is I'm going to do the incorrect, or at least, not meeting the standard version of the exec VE. I had some wondering about this because in some of the previous challenges, I saw a bunch of, it's like 2 or 3 times they used a shellcode which was very short and effectively did this in 32-bit and 64-bit. And I was wondering, well, why does the Shellcraft one have a much longer thing that actually sets up an array with sh string and then a null pointer as the second parameter? And I asked on the Discord for Ginvale, I think is how you pronounce it, who's a really awesome reverse engineering guy and CTF player, and his YouTube videos are absurdly informative and have been really helpful to me in previous instances of trying to understand more about reverse engineering and that kind of stuff. And somebody on that Discord, who I think is one of the main developers on Pwn was able to answer and let me know that, depending on the system, the shell that you are calling may require you to actually pass in the first parameter is the the shell string and do stuff properly with that. So Pwn Tools is probably just defaulting to do the correct thing, which makes a lot of sense. I'm pretty sure in my setup on Ubuntu I can get away. I mean, I'm sure because some of the shellcode that I believe I tried before from the existing shellcode that was in the walkthroughs, I think I got that to work. I might be misremembering, and I never actually got it to work other than to use my shellcode from Shellcraft. But we're going to try for this because it's going to be a lot shorter. And so that's the goal that we want to have in our assembly code, which means that we need something like RDI points at string bin // sh, and I'll put the /0 in there just to be explicit. It does need to end with the null byte. Our SI can point at 0, or yeah, it can just be 0, and then RDX I think can also just be 0, and then RAX has to be 3B hex, and then we do syscall. So we have to look for a syscall gadget. Yeah, so we have at least one of those. I mean, it's really, we just need a syscall somewhere so I can use this one and not worry about any of the previous instructions. Because I mean, we could use this and put the 3B on the stack. That's totally doable. Or wait, no, because I'd need to pop it into EAX, sorry. I don't know. We'll probably just use the one that is straight up syscall and figure out the other stuff later. So maybe I'll start going through this backwards. So we'll just copy this address because I can do the whole thing. Oh, okay. Got a tweet in there instead. There we go. Okay, so we'll have that. Yeah, the way that I'm doing this right now with like having run ropgadget on the command line and stuff, I'm actually not even going to be using the rop, where was it? Like all of this stuff. So maybe the next time I have to do ROP, I'll try to use it from here, and I'll have a slightly better sense of how to make the most use out of this. But it does feel like a lot of this stuff is organized around calling a particular function from libc. So we're returning to libc kind of thing. And we don't have libc dynamically linked in. We've statically linked everything in this binary, so it doesn't have like system call. I don't think it has execve. It could like, if it does have execve, then this gets a lot simpler. But interestingly, it has a thing to make the stack executable. I mean, that would maybe be another way to do it. Throw some shellcode in there, return to that function, and then get back to, and then have another thing to point to the shell. But I don't think so when that function returns, it'll pop the next return address, which would be to somewhere on the stack. But I don't think we actually know the address of the stack, so I'm not going to bother with looking at that. But I mean, maybe having that available is, in general, opens another avenue. I don't know. But yeah, it seemed like at least my, sort of newbie interpretation of what a lot of this stuff is doing is it is trying to find a function that you're looking to call and find it in the, find the PLT entry for that, and then return to that location after setting up the arguments using some existing ROP gadgets or just pushing stuff on the stack. So I don't know, but like these don't seem like full ROP gadgets, or I'm just fully not understanding how to read this code as a sequence of return addresses to go execute this gadget and that gadget and the next gadget. Hello, Tukang Jam, if I'm pronouncing that correctly. Wow, I'm really surprised to have viewers this time. I think 5 is by far the most viewers I've had at any given time, so thank you all for coming by and watching. Watch as I sort of fumble around trying to do some very basic, exploitation stuff, or at least it's like basic from the standpoint of folks that do this professionally. I shouldn't represent it as basic, because certainly for somebody that is where I'm at or newer than me at this stuff, it's not necessarily basic. Yeah. Okay, so I'm gonna probably just not end up using this library, is the gist of that, because I think I can find everything manually from the list of ROP gadgets that we already searched out of the binary. And last thing we'll do is we'll return to that syscall. Prior to that, we need to return to something that pops into RAX, I guess. Have anything popping to, I guess I could just say pop RAX and let's see. Of course I need to quote that. So Tukang says, I'm not really know about this thing. Can you give a short brief about what you're doing right now and what tool is that? And then Snow Override says, solve rootme.org sometimes. They have a lot of similar challenges. Let me check that out real quick. Of course, that's going to pop over on that window. I have not heard of RootMe, I think. But I would assume that it's sort of in the vein of like VulnHub, Hack the Box kind of stuff. Let me know if that's correct. But certainly this would be another good set of challenges to work on. And probably, if I had to guess, has a more holistic kind of thing. So with the nightmare challenges that I'm working on right now, which you can get at guyinatuxedo.github.com. I'll throw that link into, if I can copy it correctly, into the Twitch chat. This is, just a sequence of CTF challenges that are specifically pwnables, and I've set up a VM and downloaded all of them into the VM so that I can work on them. Which means that I don't have to do, a multi-stage kind of exploitation. I don't have to enumerate stuff to find which things are vulnerable and then get in through some level and then privilege escalate or pivot to something else. So it's a really pared down kind of thing versus, what might represent the full spectrum of pen testing or hacking in general. Which, as far as I understand it, maybe something like VulnHub, certainly Hack the Box, Try Hack Me, these services generally provide you a system that would be a more holistic kind of challenge, because they aren't like giving you, here's one program and try to get this program to pop a shell. And yeah, those would be fun to do at some point for sure. Thanks for the link. I will bookmark this, keep it in my list of stuff. So then Tukang, yeah, I'm working on these challenges from this GitHub page where somebody has gone through and collected CTF challenges that are explicitly in the category like pwnables. A couple at the beginning are just reversing challenges, but a pwnable is a challenge where you have a binary that's got a binary executable that's got some kind of vulnerable code. It's usually not a program that has very much code at all, and the only bit of code in there is specifically vulnerable to some kind of exploit, and they've categorized them based on the sorts of exploits, or at least the sorts of vulnerabilities. You could use potentially multiple exploit techniques to take advantage of it, but one that shows up several times in this stack buffer overflow section that I'm working on right now is calling, that's not a good one for it. There are simpler ones, I thought. Maybe just the first one. So read, yeah. Several of them are of the sort where you have a read call and you put that stuff into a buffer which is too small for the amount of data that you're reading in, and thus you have a buffer overflow, and you then exploit that to control the behavior of the program. Let's see, something like reverse engineering or decompiler. Yeah, so you usually use the reverse engineering techniques as a part of the process of effectively discovering what the vulnerability is, and sometimes in the process of just understanding how you might write an exploit that takes advantage of that vulnerability, you can use your reverse engineering skills and a decompiler. I have a decompiler open on the left hand side. It's called Radar, which is RADARE 2, technically version 2. And if you just search for Radar or Radar 2, you can get the page for it. It's not my favorite of the decompilers, but it's one that works inside of just like terminal rather than has a GUI. And since I'm just running a simple headless Ubuntu VM, that was the most obvious solution. If I really needed to, I could take the binary and put it onto my host OS and open it in here, let me copy the link for you. Why does nothing copy at this point? I don't understand. I could put it on my host machine and I could run it in Binary Ninja, which is another reverse or decompiler. Well, none of what I'm using is a decompiler. I'm using a disassembler. I think Radar has a module that you could add to do a decompilation stage. Binary Ninja has halfway to a decompiler. You get something fairly close to C, but it's not, I wouldn't consider it exactly like a C decompiler. And Ghidra is another very popular reverse engineering tool, and it has a decompiler. That's probably its number one claim to value, reason why somebody would use it. It's a free tool. So I'll put this in Twitch as well, in the chat. It's a free tool which has a fairly good decompiler. I mean, as far as decompilers go, it works on, small functions very well. Larger functions, it gets more stress, but I think that's true of pretty much every decompiler. And then IDA Pro also has a good decompiler from Hexrays. I don't own a license to IDA, so I'm not using it. They have a home version that's coming out supposedly this month. I haven't gotten an email saying it's come out yet, so I don't think it's available to me, but they've priced that one low enough that I might actually buy it. But yeah, the only one that I've decided to pay money for at this point is Binary Ninja, and it's been quite helpful. I find that even without a complete decompiler, the high level disassembly that they present is quite useful to me, and I'm always switching between the sort of high level and the like pure x86 assembly or whatever the machine assembly is anyways. So I've never found the decompiler results to be so good that I didn't have to worry about looking at it at the assembly level, which is even the case in these challenges that they have in this, like the walkthroughs for these various challenges will frequently have some bit where they go through the decompiled code. They're using Ghidra in their walkthroughs, so this is like the output from Ghidra, but there will be bits that are missing potentially, or it will be hard to understand. Like I think if we look at this first one, or maybe it was, yeah, so this one, we can see that we're reading into a buffer that is at wherever input is, but input was not detected by the decompiler as a buffer of a certain size. It thinks it's some kind of 8-bit in like single scalar value, basically. So in order to determine exactly how big that buffer is, they just still have to go into the disassembly and see what it thinks the shape of the stack is, where those things are laid out, look at some of the instructions. So again, even on these relatively simple functions, the decompiler isn't necessarily all that you need. So for me, especially because these are really small programs where like almost 100% of the code is something that you need to read and understand for the purposes of the vulnerability, I'm just going with the disassembly because I have enough experience to sort of work through that relatively quickly. When I do reverse engineering of much larger programs, like maybe a video game or something, that's when the like a more advanced disassembler becomes really helpful. Something like Ghidra, maybe, certainly IDA, in my case, Binary Ninja is what I tend to go with. Those are really helpful because you've got just a vast amount of code and you want to ideally not have to like look at most of it. You want to just be able to sort of sort through and find maybe this is a thing that I want to look at or that's a thing I want to look at. So after working through in the reverse engineering tool and getting a sense of what the program does, you have to work out the means by which to generate some input to that program, which will give you control over how the program executes rather than executing in the intended fashion that the original coder wanted it to work. So in the case of the challenge that I'm working on right now, the program works as a calculator. So if we say we want 5 calculations, then I can say, okay, give me an addition calculation of 10 and 39. Okay, and it doesn't like very small numbers. I forgot about that. So let's say we do 5 calculations and we do 400 and that much, and then it adds them for us, and then we can do a multiplication and it will multiply numbers, and then we could say save and exit. It doesn't actually save it to a file or anything, but that save and exit is there because that is where the vulnerability lies. Basically, it creates a certain amount of space to store the results of these calculations. So if I say 5, it's going to create space to store 1, 2, and then 3 more calculations that I could do. And when I hit save and exit, it copies the results of those calculations out of the space that it created and into a space that has a very fixed amount of space, a fixed size. So it copies from one buffer that is maybe 300 bytes long, and then copies to a space that's only 100 bytes long, but it doesn't limit it to 100 bytes. So it copies beyond the end of that 100 byte space and starts copying elsewhere, in this case on the stack. I did decompile is just to make a new DLL that can access a device. It's work, but I think this is too much. Yeah, it's... My experience is it definitely can be a lot of work to make use of the decompiled results, especially to achieve something like working with some hardware or something. I'm not sure if that's what you mean by accessing a device. I certainly don't have that level of experience of like decompiling, disassembling, just generally reverse engineering stuff to work with some particular piece of hardware. I follow a bunch of people on Twitter that do that kind of work, and it's very impressive to me. But yeah, I certainly don't have those skills yet. Yeah, I mean, I'd say I'm also kind of a newbie to all of this. My experience is primarily like software development, so I have sort of one piece of the puzzle in that I know how somebody would write this program, for example, which really does help in reverse engineering. If you have an idea of what they probably would do when they wrote it, and if you have a sense of how a compiler would turn some C code, for example, into assembly, then looking at the assembly, you can sort of see through the instructions into what the structures and semantics of the program are. And that's why I find like having the programming experience really helps with the reverse engineering side of stuff. But certainly like creating vulnerabilities and all of that, I am quite new at it. I can plausibly say that I understand the concepts behind how a lot of vulnerabilities work. Like, oh, my stream is not updating. Or at least I'm not seeing it on my thing. Are you seeing any changes to the stream? Those of you that are in chat with like, I'm still just seeing the Nightmare Challenge web page, whereas I've switched to my terminal again. Let me know if you are seeing the terminal or if you're seeing the website, because I might have to reload my stream manager. Okay, so y'all are seeing the right thing. I don't know if I should reload stream manager. Maybe I can just restart it. Okay, never mind. I just paused it in Twitch stream manager and restarted it, and it seemed to work because I didn't want to lose all the chat. I don't have a very complicated setup here. I've just loaded the stream manager, which lets me see the chat. So, okay. What was I saying? I'm still pretty new to this, and I could probably describe what some of these vulnerabilities are around array indexing, which is like accessing data that's too far out of, I mean, this is sort of like a buffer overflow, but it's probably not writing a full buffer. It's writing some location that happens to be beyond the end or the beginning of the buffer. And if you can write anywhere that you aren't supposed to be able to, there's a potential for that to be an exploitable vulnerability. It's certainly a bug. Heap exploitation is like, generally speaking, I think that's about allocating a bunch of stuff on the heap using malloc or a similar kind of runtime dynamic allocation, and then deallocating a thing in a way that you have like you can ensure allocation happens at a certain location that you have control over. There might be multiple different mechanisms in there. I guess double free, use after free. Like if you know that something is using a pointer after it's been freed, and then you can ensure that you've allocated that memory to yourself and control what's in that memory, then they're using it. They're using data that you have control over, and that's how you get control over the program. But like this is me explaining it at the level of somebody who's never done it, so I'm sure there's going to be a lot more details into exactly how to make that happen, and I'm excited to get further on. Okay, but I've done enough dilly-dallying. I should probably get back to actually trying to write this ROP chain, see if we can get this solved. So I was looking for a gadget that pops RAX. We've got one right here. So this will pop a value off of the stack and into RAX. And that's good enough for me. My copying really doesn't seem to want to work today. Okay. So we will pop something from the stack into RAX. That's all good. We have to have it on the stack first. So I'm going to list stuff to have on the stack right here, and presumably I will have to intersperse it amongst the return addresses, but I don't honestly. I'm gonna like defer the thinking on how that needs to work for right now, basically. I'm sure that, yeah, I'm gonna like think about exactly where I need to put those things at some point in the future. But what I can do is just say 0x3b as a quad word. Presumably everything that I'm pushing on the stack has to be a quad word because I am 64-bit, so if I'm popping something from the stack into RAX, then it is going to pop a quad word off. I guess I could search for like pop EAX. Don't have any gadgets for that. Yeah, that's fine. So this just means that I'll have to make sure that when I am writing what goes on the stack, I get a full 8 bytes and not just the 1 byte for 3B. Okay, then, so that gets us racks. RDX has to be null. We could look for, I mean, I could do everything through pop, and maybe that's the simplest way. If there is like an XOR RDX, nope, okay. Maybe RSI? No. Okay, so, and is there pop RSI? Yeah. All right, so I'm just gonna do like a single pop for each of these. So we'll get pop RDX and then the return. And then we'll do pop RSI and then the return. And the next one is going to be the one that is actually slightly more complicated than these, which is we need to get a pointer to this string into the what am I saying? Pointer to this string into RDI. I think one approach would be find that string in memory if it exists already, So I could run strings on simple calc and see if there's a bin sh. Just ignore the slashes. There's no /bin/sh. Maybe just sh would be enough. I don't know, and I'm like, maybe we could just link to the end of this string here, which would be sh null, and maybe that's enough. But or one of these other ones that ends in sh, I am going to try a different route. And I don't know why I'm going to try this, because I do feel like it's probably slightly more complicated. But I could include this in the data that's being written to the stack, and then pop, or not pop it into a register, but push or move RRSP into RDI. So if the top of the stack is where this string begins, then moving RSP into RDI means that RDI will point at that string. Is that really worth doing? Well, first thing I could do is see if I've got a move into RDI from RSP. I don't have that. Maybe there's another option for getting that string from the stack in there. I don't know what the stack address is, so I can't just put a explicit address on there. And certainly I could, like, maybe I could do something RSP. Is there any move? Well, what is this one? Move RSP into RSI. So we could potentially go to this or one of these other ones that moves something into RSI. And then, moves RSP into some register and then move that register into RDI. So if we look for move RDI RSI, don't have any. What about, where was the, thought I saw one earlier up here. RBX. Oh, that moves RSI into RBX. And then does syscall. That's not what I want. We could do push RSP and then pop it into RDI. Yeah, so we could get that string onto the stack, then push RSP, and then pop into RDI, and now RDI would be a pointer to that string. So I think let's try that, and maybe the walkthrough, once we read about it, if I can get this to work, I'll go through the walkthrough afterwards, and at that point maybe they'll have a much simpler way. Maybe finding that string as just sh is enough. I think execve, my recollection is that they have these P versions in libc, or in POSIX, I guess. It's not in it's not a libc thing. So if we call execve, that does have the environment. That's what the E is for. And the P version says search for a given file name on the path. Use the path environment variable to look up this thing. So that's sort of like how it works when you try to run a program on your terminal in your shell. It's going to look through the entries in your path and try to find the file that way. But if we're just calling execve, since that's the underlying syscall, I think we don't get that behavior at all. So I don't know if just calling sh by itself without the full /bin/ prefix on there is actually going to work at all. So I'm going to avoid that, but then, maybe the walkthrough will say, oh, you could have just done that, and that would be simpler. We'll find out. All right, so we'll push into RSP, and then I just need to pop into RDI. We have one of those as well. Seems like it's pretty easy to find push and pop gadgets for maybe every register. At the very least, the original 8 registers. And maybe that's all you need with enough. Obviously, you want to go with a short ROP chain if you're space constrained. I know on this one we've got 1,000 bytes of overrun of the buffer, so we shouldn't have to worry about space in terms of how many gadgets we can put in our ROP chain at 8 bytes per gadget. All right, so reviewing this before we get to the before I try to actually turn this into a sequence of data that we'll put on the stack, and then we have to do more work because the way that you get that stuff on the stack with this simple calc program is a little bit more involved. I can't just write a string of binary and say this is the input. So before I read through these instructions, I'm going to make sure that I remember everything that I need to put on the stack. So earlier I need to put the string /bin/ sh0, which is exactly 8 bytes. So 0, we do okay, H is 68, and then S is 73, / is 2E, I think, 2F, and N comes in at 6E, I at 69, of course, after H, then 62, and then 2E again, 2F, sorry. So we got 1 byte, 2 bytes, 3 bytes, 4 bytes, 5 bytes, 6, 7, and 8. Okay. So we need to put this value on the stack, and then we can have these two instructions. When we, so if the stack pointer is here, so we need to, let's see, because I'm thinking start a ROP chain. The start of the ROP chain is the first 8 bytes are going to be where we are overwriting the return address from the function that we are taking control of. So when that ret instruction runs, it will take those 8 bytes and pop them into RIP, basically, meaning the stack will move up 8 bytes, RSP will move up 8 bytes, and now point at this value. And then we will, and when it runs the push, then we'll add another thing to the stack. So I need space on the stack for that push to happen. Well, no, the push will subtract from it. So this location where we had the original return value for the first gadget will get overwritten with the value of RSP. Is that right? If we're pushing onto the stack in our ROP chain, then we need to, I need something that is going to modify RSP to skip over this value. So if like up here at the top is a lower address than down here at the bottom, when we have the stack pointer points at this address and we push that into RSP, then, or sorry, if we push RSP onto the stack rather, this is where the RSP will show up. And when we later pop it into RDI, so we need that up here. So then if we run this pop, well, before we run the pop, we're going to run the ret, right? And, oh, maybe I just can't do push RSP. Or I need push and then modify RSP before doing ret. Oh, maybe I just can't do this. So my concern is that when we push the stack pointer value onto the stack, now RSP is going to point at the stack pointer value. And we're going to immediately return, which is going to use the value at the stack pointer as the instruction to go to. So we could push RSP if the thing that we are pushing, if RSP happens to be a executable thing, but it's not because we've got NX bit. Like if we needed to do this to what am I saying? If we needed to do this to get running some stuff on this, like that we had already written our shellcode to the stack and we could execute it, but we just didn't know where the stack was, we couldn't just put a fixed address in the return or a leaked address in the return. Maybe in theory we could push the stack pointer and then return, which would go to that, assuming that the stack pointer was pointing at the beginning of our shellcode or a NOP sled or something. But in either case, we're not going to be able to return to an address on the stack. I don't even know what that gets used for in the like intention of the code. I mean, maybe I'm just confusing myself. That certainly happens a lot, but in this exact moment, I don't see what push RSP ret would even be doing for the program in its intended behavior. Oh, I guess, I mean, in theory, this doesn't have to be an instruction that was actually intended by the program. It could just be some location which had that sequence of bytes that decodes to that. So maybe we'll chalk it up to that. But what I would need to do is modify RSP before we return. And I just, I feel like that's unlikely. We could push some other stuff before we get a syscall. That doesn't help. Let's see. Trying to see if there's any push RSPs that would return something useful or would do something before the return that would help us out. I should look up what retf is. I don't know what that function is that then takes a parameter. But yeah, I don't see anything that allows us to... Damn. Okay, maybe I have to think about this differently. And either jump to that string that's like just an SH and see if that works, or figure out a different way to get a stack pointer into RDI. I mean, if we could get something into RDI that was an RSP sort of offset, then we control enough of the stack that we could probably get that to work. So let's look for move stuff into RDI that has RSP. Okay, so we could, oh, and that's just and then a call to a certain address. I don't know if calling an address like that helps me out. I don't know what would be at that address. Let's see if we can look at it. If it's actually... I don't see any function there. So, I don't know. Again, that might not have been intentional instructions. But are those both the same thing? No. Two different places that say call to that address. Maybe they're calls to an offset which happens to both be that address offset from the location where that instruction is. Or, whatever it is in like what's the base address? I don't remember enough radar commands to be able to be like, find me the base address of some memory. No, okay. So we want to move stuff into RDI. Let's see what gadgets we have for that. I really just want a ret rather than jump or a syscall or a regular call. No. There's no move RDI which has a ret. That's interesting. I mean, I guess it's not like interesting as trivia, it's just I'm a little surprised I think I was just hoping, you know. So how can we get something to RDI? We can put the address of that string. I mean, let's just try the string approach, I guess. Will this let me get a string? Yeah. So Rob Gadget binary simple calc string sh. Let's just double check there's no /bin/sh. No, didn't think so. Okay, so we've got a lot of places where we've got the string sh. It just doesn't feel like that's going to work. I could write some C code that maybe calls the syscall. Is that how I want to do it? I think that's don't take too long. When we could just try this. So all right. So I pass in an address. I mean, like, if I seek to that address, let's actually copy it. What do we get there? Yeah, okay. So, I mean, the addresses that I'm getting from Rob Gadget are at least valid for the data segment. I think those calls were simply to some gibberish location. So whatever the ones that ended a call probably just wouldn't work unless there's a different way to take advantage of a call. And you know, maybe that's one of the things, one of those techniques I would learn if I did the ROP Emporium challenges. But for now, I'm going to try to keep it as simple as possible. Take one of these sh strings and put that on the stack instead. So there we've got the string sh0, which will be on the stack, and then we can pop that into RDI. Pop the next thing into RSI, which is just going to be zeros. We'll pop that into RDX as well. And then we'll have this one. And we'll do the syscall return. So let me walk through this before I try to get it into the form that will run in the program. And maybe we'll just do it through GDB the first time through to verify that what I'm thinking is correct. I mean, obviously we'll end up doing it through GDB multiple times maybe if what I'm thinking is incorrect, but I don't think I'll just run it right off the bat like I do with some of the earlier ones, because I feel so shaky on whether or not my thinking and my analysis of how this works is correct. But this first one, this line, is going to be what we override the return pointer with. So that's not going to work. This will be the value just before that. And then I think main was the function. So this one will will override the return address from main. And in which case we need the next thing to be the address that gets popped into RDI. So RSP will start here when we run the ret from the original main function. Then it will run pop, and so when that ret happens, then this is where RSP points. And we'll do pop RDI, and so it will put this value into RDI, and then this is where the RSP points next. So when we run the ret, we need the next value to be the point, like the address of the next gadget. So to do this, when it'll run, like RSP will point at this when we do this ret. Afterwards, after the ret happens, then RSP points at this value, which we then pop into RSI. And then RSP points at this for the second ret in our chain. And after doing the ret, RSP points at this value. Then it does the pop RDX. And does another ret. And by the time that ret happens, RSP points at this one. After the ret, RSP points at this value, then we pop into RAX and do one final ret. And when that ret happens, RSP points at this one. So it runs the syscall. And then I think we're good. Yeah, so I just had the order wrong. We need to do the instruction. We need the pointer for the gadget before the value that is being popped in the gadget, since all of our gadgets except the last one are pop. Okay, we'll give it a shot. We'll see what it looks like in GDB, I guess. This is not actually assembly, but I'll save it as assembly file anyway. We'll open up our exploit file, and now I have to remember, it's been a couple days since I've actually worked on this challenge, so we can, the way that we do stuff is we need the results of our calculation to have the value as a double, or as a D word rather, not a floating point double, just a integral double word. So the result of an add or a subtract or whatever gets put into this buffer, which then gets copied to the stack. So our way of writing a certain thing to the stack is to run some particular sequence of commands to say, in this case, we're doing this 18 times. We run number 2 says to do a subtraction, and then we give the value 40 as the first operand to the subtraction, and value 40 as the second operand. So then it's going to write a 0. It's going to subtract 40 from 40, calculate 0, put that into the buffer, which gets copied to the stack. Yeah, and I was going to write something that, like, oh, I guess I did write it before I got to the point where I realized that like it's not even possible to do the thing that I'm trying to do with this shellcode. But we could. Oh yeah, I remember. In this version, I thought maybe I could put the shellcode in the fixed addresses that are in the data segment. It doesn't like stack allocate the parameters to the subtraction or addition or multiplication function. It has them statically allocated, so they show up in the data segment or BSS maybe, BSS section, I guess. And so I thought, oh, maybe I can put the shellcode in there since they're all in order in memory, and then I would get like 6 bytes and I could jump past a bit of null bytes and then do the next 6 bytes that show up from the multiply. Like this is where the add happens, this is where the multiply happens, and divide and subtraction, I think. But none of that was executable either, so I wasted a bunch of time on that when I could have just looked at the memory permissions and realized like, well, it's not going to execute any of that stuff even if I put my shellcode in there. So, but the same concept applies as some of this other stuff. Like we just need to put 2 parameters where if we add them together or we subtract them, something of that nature, the end result is one of these values. It's convenient that all of these are, I mean, it's very slightly convenient that they're all fit in the D word, and so I just know that I need, between each one, I need to write a 0 quad word, whatever it is. Yeah. And that should be enough. So I'm going to make an array for our ROP chain. I guess I don't need to put a comment on there. And oh, I didn't insert, whatever. Okay, so how do I want to do this? And then there's a certain point. Oops. There's a certain point at which we need this to be, yeah, so we still need to put in, oops, this sequence first. Just as junk to fill up the buffer before we overflow and overwrite the overwrite the return address. I'm gonna put it all as nulls because one of these addresses on the stack needs to be null because we call free on it. So if we call free on the null pointer, then that's no op. So I'm just gonna put all nulls in that buffer up until the first location where we override the return address, and then all the rest of these are gonna just come after it. And I need commas between all of these. Okay. So we're going to loop through that, and we are going to basically do this. Pretty sure. Just going to call it value. So the first one, we are going to add 40 and the lower D word of each quad word. So the first value we write is going to be this piece, and then we'll write the other piece. Since I know these are all zeros, I guess we'll just do it the right way anyhow, but we'll shift the value and then do the anding and whatnot. I guess we don't even need to shift it. Or I'm sorry, we don't need to and it. If we do shift it, then we've got zeros up at the higher values, so that should be fine. Okay, so yeah. So the lowest value that we can actually use in an add instruction for this simple calculator is 40. So we put the first operand as 40, and then the second one we will take val, we'll just get the low D word, we'll subtract 40 from it, so then the add result should be the low D word from val. Then the next one, we will do val left shifted by 32 bits minus 40, and that should be fine. Yeah. I don't know why I bothered to write it this way. Like, I could have just written... Could I have written negative 39? I don't know. That's a good question. Let's try it in the calculator. If I have to provide positive values for both of them, then that gets a little more... what do I have to do? Oh, right, because it has to be greater than 40. So I do have to provide it as that minus 39, I think. So if we shift the thing by 32 bits, so we get the high D word out of that value, and then we bitwise not it and subtract 39 from there, then adding back 40 should get us the right thing. And I know that it worked using the unsigned math when I did it before, so I'm sure that this approach should be acceptable. Okay, so that will push all of that stuff onto the stack. I mean, maybe that's all we need. And then the last thing we do is, oh, and I was using 2-byte indentation. So last thing we do is send 5 as the command. Should I... I'm going to put the ROP chain up here. Because I want to calculate the right number of things that we need to put in. So we need 18 plus 2 times len ROP chain. Pretty sure. And we need one more because the way that the program is written, the way the program is written, if you actually get to providing the info for like the last calculation, so if you put in 3 as your number of calculations and then you actually do 3 calculations, it doesn't come back to the menu and let you select save and exit. So we need an extra one that is left over that we aren't actually going to use, because at the very end we're going to call input 5 or like menu selection 5 to do the save and exit to trigger the overflow and run our vulnerability. Okay, so I think this should work. I still haven't gotten around to working out my issues with GDB. I did watch somebody going through these challenges before, or on another Twitch stream, and they were using GDB attach, and the behavior that I saw is like if you were doing that in a GUI environment, it popped up another terminal, like it popped up another Xterm window with the GDB client running in it. Since I am running this like headless and I'm just SSH'd into the VM, it doesn't seem to work right off the bat for me. I'm sure that there's a way to do it. I just haven't looked into it yet. So I'm not calling GDB attach from within Pwn Tools. Instead, I'm doing a really hacky thing, which is when I run the exploit, it sends whenever I call send line, I've actually wrapped that and I just write it out to a file. And so we open up exploit.txt, do all of our thing, and all the input that we send also gets written to that file in order to... There might be a simpler way to achieve it where I could say, like, get the input pipe for the target process tube and pipe that to another file, but this worked well enough for me. So at the end of running this, we also have an exploit.txt. I can show you the old version that we have. And what I can do, and since this is like, in this one, we don't even have to send in anything that is binary data. It's nice and easy to open it up in Vim. But I just pipe that in GDB, and it will run the exploit as well. That's worked for me in all the previous ones. So that's how I'm going to do it here. So unfortunately, it did not finish. It hit that on line 44, which seems earlier than I would have thought. Okay, so we got an issue running it on this one. Maybe we're not doing... Well, I did put the parent at the wrong place. It shouldn't matter, I don't think, because it's just the order of operations. But we'll run it again. It's probably going to fail. And now that I have the exploit.txt, we can see where it starts to get into yeah, I guess I could have done, well, whatever. Oh, why is it sending -40? Okay. We are actually... So if we have, let's say, how do I want to do that? I do... All right, so the issue is my attempt to get the like unsigned version of -40 as a D word did not pan out. And I could spend my time trying to figure out how to make sure that Python does the thing that I wanted it to do, which, oh, I didn't. But since I know that all of those top ones are, since I know that all of the higher D words in the values in our ROP chain are all zeros, then I'm just going to use subtract and subtract 40 from 40, and that'll give us a 0 in that higher portion of the quad word. Okay, still errored out. I'm still getting -40s in some of these, so I'm doing something wrong. Oh, because of the ones that are, I'm actually trying to write a 0 in there anyways. Cool. Then, I just need to get better at Python coding, I guess. But I'm going to do a quick. Can I write a. I can. Let's just do that. So. Okay. So I'm just gonna write a function to do the subtraction one because we're gonna have it a couple times. And then we'll use T instead of target. Okay. So we'll say 0 result, F and target. And up here we'll have if val is equal to 0, then we'll do 0 result, F and target, else, of course, need to fix the indentation levels in Vim, but whatever. So yeah, we'll send a 0 result for the low quad word if the full value is 0. Otherwise, we will send whatever the thing is for that low quad word. And then for the high quad word, we are always sending 0. It's deeply hacky from my point of view, but hopefully it will work. Well, that definitely got further. But it's that's just because I wrote it wrong. I guess it didn't get further. It got a different error. Oh, because I was opening. Okay. So did I write it in the? Oh yeah. Whatever. Let's just do F comma T. Okay. That one. Got to line 54. Down here. Why did this one fail? It's the same location, I guess. Okay, so let's look at the TXT. So we send a whole lot of nulls, which is fine. Let's see. So we're doing 37 total. That should include 18 like spacers. You know what? Why don't I just, for the spacers, we will do we'll just do a different value to make it very obvious when those stop. Okay, and then our first one is this, and then the null for the high D word. Second one, and the null. Third one, and the null. Then we've got an actual null, full, like, quad word of null. And this adds 59. Okay. Why don't we have the stuff following it? Because we got some exception from EOF. Okay. So, okay. So far it actually looks like what I wanted it to say. So if we pipe it into simple calc. Oh. Ugh. Yeah, okay. The problem is, I wonder if that was like the main intention of them having the small thing. Because getting around it for the zeros is easy enough. I might have to do the right thing. So now the issue that I'm running into, and maybe y'all who are on the stream, the person that's watching, thanks for sticking with it. Maybe you saw this and I've just been waiting for me to actually run into it. But one of the values we need to push in is 59. And if our add is basically less than 80, then we don't have an easy way to use the add instruction to accomplish that. And so what should I do? We could just use subtraction. So why don't we go that route? Maybe I've just been making things more difficult for myself doing subtraction. So let's do like, oops. I'm gonna make this function put a particular value on the stack, and it's just always going to be subtracting, let's see, if the value is 0, then we want to let's say we always start with, okay, with the what, uint max 4 billion whatever, as the value that we're subtracting from. And then we subtract from that value as the second thing. I like that. I mean, I don't know why I didn't think of this earlier. I've just been going and not pausing to think about stuff. So what we want to do is say the low value the low D word of value and then the high D word of value. That's what we are going to pass through with the subtraction. Let's look at what we have in here. Okay. So we have all those nulls for the junk. Then it looks decent to me. Yeah, and this went all the way through actually and got to the 5. So receive until colon space. Oh, that might be, I might have actually gotten this to work. Because I had this line when my initial iteration through was to put the address of the main function back on the as like have main return back to main, and then I was looking for it to print out all of this stuff up through the colon and the space. So since we are not doing that anymore, I just want to go interactive and maybe this runs a shell. No. Damn. Okay. And I guess we were getting EOF rather than like just waiting forever to receive until that. So let us see what happens. Do I want to run it just without GDB? Okay, so we get the seg fault. I guess I saw that earlier. So we're going to run it in GDB. And just do it full screen. Let's put our breakpoint on the return, and we can follow along with what's happening, what's on the stack, and all of that. So I think I need to say star main plus 518. Then we run it with the exploit.txt. And now, what is the address? Right, so we're going to return to this pop RDI ret gadget, which is the first one we had. Good. And the value, oh, okay. I put the wrong thing as the string, because this string, it has sh, but it's not the end of the string. So let's fix that first. So once we do the ret, it's going to use this value. It's going to pop this off of the stack into RIP, and then it's going to pop this value into RDI. But according to GDB with Jeff, that value points at this string, which starts with sh rather than ends with sh. So this is not the name of the path that we want to run. Okay, fair enough. Then I want to want to run ropgadget string again, not with bin sh, just with sh, and find, oh, I guess I had it here, didn't I? Okay, so this address, I'll copy this out. Will be, oops. Okay. So this is the address of sh null. Any chance? No, didn't think that was going to fix it, but certainly a thing that we need to fix. So we're still going to run it in GDB. We're still going to put that breakpoint on and then run it with our exploit. So we are going to pop into RDI with this string as, as the value that we want to point to in RDI. And then we will return, and it's going to return to pop something to RSI. And RSI is going to be null after the pop. Okay, yep. And then pop RDX. And RDX is also going to be null after the pop. I guess we didn't need it because RDX was null to begin with, but I suppose it doesn't hurt. And then lastly, what are we going? Yeah, 3B is what we're going to pop into RAX before we go to the syscall. Okay. So what does this look like? Is this where we're going to get the issue right on the syscall? No. Oh, well, I haven't actually done it. Maybe I need to follow the child. Oh, So it seems like the syscall didn't do anything. Is that accurate? Can I just run it in strace? Okay, so we're doing the exact, but it's just sh is not enough. So that's what I was thinking as to why I was not trying to use that string in anyways. So what do I want to do? Oh, well, another route that I could go, maybe. Okay, we need to, so if we're going to put the string on the stack somewhere, we need to get RDI to have a pointer to the string on the stack. We don't know the address of the stack, so we need to put an address on the stack into some kind of register. It doesn't have to be RSP directly. It could be RSP with an offset. But I think what I was looking for before with some of these move instructions, like if we're going to calculate an offset with RSP, then actually we're looking for an LEA, not a move. Because if it's like move RDI RSP plus 38 or 32 or whatever, oops, that's going to dereference the value at that location on the stack. But we need RDI something or other. So let's look for that. These seem unhelpful. So let's look for an LEA with RSP somewhere on there. And a ret. Okay. Maybe there's a different way to get a stack pointer into a register that I'm not thinking of. I guess we could be using RBP, but that's like we don't have control over that as much. And so I think it would be more annoying to modify RBP, but I don't know. Maybe we have some good instructions that involve adding to RBP and then returning some for some reason. Divide RBP. I guess it's just not using it as the base pointer. It's mostly popping RBP. I feel like I might be getting off on the wrong track right now. So we know RSP can be set up to point to the address that we want it to point to. You know what? Maybe I'm making this more complicated than I need to, actually. So if we push RSP okay, let's say we had a push RSP here. When we return from the main function and return to this address, RSP is going to point here. And then we push RSP onto the stack. So it writes RSP at this location, and now this is RSP. I think I was probably just thinking about it incorrectly. Because now, if RSP is here, this is just where we put the address of the next gadget to return to, which would be the pop RDI. But the problem is after the return, this is where the stack pointer is going to point. So we would need to subtract RSP. We'd have to subtract 16 from it. You can add to RSP and then pop. We can do this. We'll need to put in some junk because we are changing RSP a bit. Oh, well, here's a useful one maybe. So is that useful? I think we need to subtract, because, and that's going to be difficult. Okay. Because if we add RSP, it's going this way, assuming the higher addresses are down here. And we've already pushed the address of our like string on the stack. Can we do that? I mean, maybe we could put the string somewhere and then like do one of these or something. Of course, that's moving a D word, and we need to move a quad word. So let's see. We've got what? 10, 20, 30, 40, 48. So we're looking for maybe like 50, 58. Okay. Interesting. Is there something that we can get out of that? So adding to RSP, would that help us at all? We need to okay, rather than like sit here and puzzle over it like a person with serious trouble thinking about this stuff, I want to understand when the stack pointer is known. Like, because some of these examples involve calling a function that does take a string argument, like calling exec ve in this particular example. And so how is this supposed to work then? Is this only going to work if the how to phrase it. So yeah, if we know the stack pointer, then we can locate our strings as part of the ROP chain. We can put our strings in there that'll be put on specific addresses on the stack, and then those addresses can show up in as values on the stack that get used when we call something. But I don't think we know those addresses. Maybe I should double check that. I don't know that I have a good way to double check that, because if I run the program in GDB, then it's definitely not running with ASLR. And I think my understanding of using checksec turns out to be like, I thought even if you have no PIE but ASLR is on for the entire system, that the stack would be sort of randomly allocated where it starts from. I mean, does this call work just because the calling convention of read is to take everything from the stack? It feels like that's the only way that would work. So, okay, I thought maybe there would be a really obvious example here for how I would get string on the stack into a pointer to that string on the stack into a register using ROP. But I don't see any examples of that in this case. So maybe there's some advice in here. Yeah. Didn't see anything that seemed most helpful in this case. So I need to, again, get a pointer to somewhere on the stack. Maybe I am making this more complicated. Oh, that would be nearly doable. Nearly. Oh no, that's doable. Okay, okay. So we're going to use a feature. We're not going to put something on the stack. We're going to use something that I mentioned earlier in the stream when I was talking about an attempt that I had made that didn't work, where I was attempting to put shellcode in these addresses. So as a quick review, if we go into the adds function, this is the function, this is the basic block that gets run if the item you select on the menu, if we select 1 to do addition, does a compare against 1, and if it is equal, then we come down here, we call the adds function. It's going to take one number and then a second number and then calculate the addition of those and put it into memory address. It puts it in this address. So why didn't the, okay. And it puts the operands in their own fixed memory addresses. The first one is called obj.add, and the second one is just this address, I think. So, right. So this is at 4A80, then the next one is 4A84, and then the result value is at 4A88. So, oops, sorry about that. That means we've got 4 bytes plus 4 bytes here. So we've got 8 bytes of space in the operands that we can use with our pointer. We don't have to care what the result of that calculation is, as long as those operand values in order have the value of the string as ASCII encoded, then we're good. And since the string, including the null byte, is exactly 8 bytes, we should be able to use that memory and then point to it. Since it's a fixed address and we're not using PIE, we know this will be at exactly this address. Although I'm not going to use the add one. I guess we can use the add one because we're no longer, our exploit doesn't use the add command anymore, I think. We use subtract and subtract. Yeah, so we're good. So we can use the add command to store the string in writable memory and as the operands to the add command. Okay, so what I'm going to do is make another function. I mean, it doesn't really need to be, but we're going to do it anyways. Okay, so we need to take the string, encode it as bytes, and then reverse it and read that as an integer. So let me just play around with it in the in the REPL. So if our string is, let's do just the /bin part, because this will be the first chunk. Like we'll have to do it in 2 separate double or D words. So the first bit is going to be /bin, and if we do s.encode, we get that as binary, and we could say what, U32 to get that number. Then what does that look like if we say P32? Okay. And we just said like hex coded that. /bin. Okay. So that works for me. And that needs to be, oh, but it actually is in the wrong order. So we'll have to write the string backwards, I guess. There's no like reverse. Okay. Right. Yeah. So you can't just reverse the order of a sequence of bytes. It's no fun. Then how do I want to do it? Can do, yeah. Okay. So if s is actually /bin/sh and then a null, right? Yeah. Then we first need to do 4 onwards. 5 onwards? No? What is... Oh. So do I need to do... Okay, and that'll be /sh. No. Okay. And the prior one would be... Or is it 0 to 4? Okay. Okay. So the first bit that we put in is going to show up at the lower section. So that's going to be U32 or S converted to a string from the 32-bit unsigned value of S, and we need it to be the first chunk. Reversed, encode, and this one is going to be the second chunk, reversed. Is that enough? What do we, oh, it's just a shorter line, yeah. Okay. Let me think about that for a second. Yeah. All right. So we will do Only 17? And then we will store stuff in the add writable fixed memory addresses. And then our address of bin/sh in the add operations operand buffers. I don't know how to put it. So that's going to be at 4, where was it? 6C 4A80. Okay, let's see if that does it for some reason. If that actually works. T is not defined. What have I done? FT and S. Put string. Oh. Okay. Sure, I need to put the null byte in there. Even though, yeah, I guess I just do need the null byte directly in the string. Okay, that's something, I guess. Invalid number of why is that an invalid number? 36 should be valid. And I still need it to be 37 actually. But padding is only 17 now. No. Okay. So when I run it, why do we get invalid number right away? If I run it and I say 37, that's not invalid. What's going on there? So they seem what we want. And then when we run it through Pwn Tools, we get a seg fault. We don't get like an EOF after this. So, because I'm running it with .py, not .txt. Okay. All right, so we are seeing the seg fault that way. So let's run it in GDB. I'm going to set the follow fork mode to child in case we manage to pop a shell somehow and it's still seg faulting. I don't think that's what's going on, but that's happened in the past. Set the breakpoint at main plus 518 and then run it with our exploit.txt input. Okay. And I didn't need to reverse the order. Why did I not need to reverse the order? I thought I thought when I did U32 and then hexified that result. Oh, no, because that's just the hex of the digits, not the hex of the little endian encoding of that integer. So it's a hex of that number, sort of, I don't know, raw, like unassociated with how it would be stored in any memory. And so it will, okay. In any case, we don't need to reverse those. Fair enough. Does it work now? Oh my god, it works. All right. I feel pretty good about that then. I mean, some flailing around. Definitely spent some time thinking of how to write this data to the stack and get a pointer to it when I already had a place that I could write data, and at least enough data not on the stack to use for my purposes. If I had to write a really long string and use that somehow, maybe I would still have to figure out how to put something on the stack and use ROP to get a pointer to it. It feels like, I mean, there's potentially some gadgets that would work for that, but like something simple like push RSP or is just like, that seems like it's always going to result in a crash. I need to do more thinking about ROP stuff. I certainly should go through that ROP Emporium set of challenges and just get more experience with it. But I'm really glad that this works. This feels like the most, maybe not the most frustrating piece. Granted, I spent nearly as much time on doing this challenge in a previous stream, so this one challenge has been maybe 4.5 to 5 hours worth of, like not getting it. So maybe in total it's more frustrating than the other ones, but there have been some other ones that were a little more finicky even after I knew what I was really should be doing. But this feels the most satisfying in terms of learning more stuff and just sort of having to think about how my chosen shell, like I put more work into figuring out the shell code on this than any of the other ones where I was just like, give me whatever shell code Shellcraft does and I can read through it and maybe customize it if I need to, but I wasn't like building one from scratch and not doing one using the constraints and techniques of ROP. So that feels really good. So I want to read through the walkthrough and see what they decided to do. It seems pretty likely that they came up with a simpler approach than I did. So maybe we'll learn something to use on the next one as well. I guess I'll start from the beginning. I did go through a little bit of this on the last stream, but maybe you're not watching the last stream, so we'll just take it from the top. They start by looking at the binary with file, and they see it's a 64-bit ELF binary for x86. And then they run checksec on it, and they see that NX is enabled. I did see that myself, but it didn't I think I just don't have enough experience to where that stays stuck in my memory as don't even bother going down this route, because I remember, I'm sure that if you go look at the previous stream where I started working on this, I did rattle off, I went through checksec and looked at it and said, oh, NX is enabled and whatever, but then must have immediately forgotten because I spent a lot of time trying to come up with ways to put shellcode on the stack and failing at that. So yeah, and then they run the program, and they immediately get a, oh no, they get an exit. They don't get the seg fault. But if you put in 50 or really any number 20 or higher, and then eventually do save and exit to get out of it, it will seg fault. And that sort of gives you an indication of like, oh, there might be a, buffer overflow kind of attack available if you're getting a seg fault just without even trying to overflow a buffer. Yeah. All right, I'm just going to read what they've written. So we can see that it is a 64-bit statically linked library. The only binary mitigation it has is a non-executable stack, so we can't push shellcode onto the stack and call it. When we run it, we see that it prompts us for a number of calculations. Then it allows us to do a number of calculations. Also, it apparently won't let us calculate small numbers. When we take a look at the main function in Ghidra, for me it was under a folder called main ... we see this. And then they have a printout of what Ghidra has decompiled that main function to. We set the buffer mode to use a 2-byte buffer, I think is what it's saying there. Either way, we're setting like a very small input-output buffer, which can be pretty handy when you have stuff that is crashing. Then they print the message of the day, or just sort of the banner when the program starts. They ask for the number of calculations that you expect to enter. They scan F to get that number in. They move past the new line in the input buffer. They check whether or not the number of calculations is an acceptable value. This 100 hex is far larger than than this vulnerable buffer that they copy it into at the end. So that's where the vulnerability lies. But you can also not do less than 4. Otherwise, it just prints out invalid number. That actually is what I was running into when I was trying to run the Python script itself as input. So maybe that's helpful. Sort of helped me out. I don't know. And then they dynamically allocate a buffer that's large enough to hold the calculated results, each one being 4 bytes. That's why they shifted over 2. So 4 times the number of calculations, however many that is, bytes. We dynamically allocate, then they loop through however many calculations times, printing out the menu, scanning in your menu selection. If you choose 1, then they do adds, and they put the result into that buffer they dynamically allocated. If you chose 2, they run the subs program or function and put the result in the calculations buffer. Same thing for multiply and divide. If you choose 5, then they mem copy the whole calculations buffer. They do the whole length of it, however big it happened to be, into the vuln buffer, which is a fixed size buffer of 40 bytes. Then they free that dynamically allocated buffer. That's the free that we need to make sure that a null byte is written when we overflow. We need to write a null byte to where this is on the stack. Otherwise, we'll just get a crash here. And then they're done. And otherwise, they print invalid option. If you come through the whole thing and don't ever select 5, then it won't do the mem copy. It'll just free and exit out of the program. So yeah, that's pretty much what I was seeing in Radar in the assembly code. Continuing on with their explanation. So we can see that it starts by prompting us for a number of calculations with the string expected number of calculations. It stores the number of calculations in number calcs. Then it checks to make sure the number of calculations is between 3 and 100 hex. If not, it will print invalid number and just return. It will then malloc a size equal to number calcs shifted left by 2 and store the pointer to it in calculations. This is the same operation as number calcs times 4. Just check out these calculations to see, and they prove that that's how shifting works. Here it is essentially allocating number calcs number of integers, with each of them are 4 bytes big. Then it will enter into a while loop that will run once for each calculation we will specify, unless if we choose to exit early. Looking at the assembly code, since the decompilation looks a bit weird, for the multiplication section, we see that it is calling the moles function. Yep. When we look at the moles function, we see that it checks to ensure that the two numbers have to be equal or greater than 27 hex. Looking at it, we see that it pretty much just multiplies the two numbers together. It has to be equal or greater than? I thought it was just had to be greater than. Oh, I guess that's my bad. So we could have used 39 instead of 40, but whatever. Looking at it, we see that it pretty much just multiplies the two numbers together. Looking at the other 3 calculation operations, they seem pretty similar, but they do whatever that operation is. Okay, and then they have an example of what the moles does. It has those fixed addresses where it puts the operands, and then it does the multiplication with them and stores it in a fixed location for the result. Prints out the info about that operation and returns. Okay. However, we can see that there is a bug that resides in the option to save and exit, and they show you the memcopy and the free. If we choose this option, it will use memcopy to copy over all of our calculations into vulnbuff. Thing is, it doesn't do a size check, so if we have enough calculations, we can overflow the buffer and overwrite the return address. There is no stack canary to prevent this. Let's find the offset from the start of our input to the return address. We start off by setting a breakpoint for right after the memcopy call, then seeing where our input lands. It's also that value in, that's the like sentinel value that they're typing in to look for it in memory. So yeah, their approach to finding the size of the buffer that is allocated on the stack is to use GDB. I just saw it in Radar because it will print out, we go back to, so if I see that we are calling, where is it, malloc with this as the, where's RAX from? But we were, oh, sorry, yeah, it calls malloc and it puts, no, it's from the call to memcopy. So we call memcopy and we've got local 10, which is the address where the malloc result is stored, and then the local 40 is an address on the stack. And it's called local 40 because it's RBP minus 40 hex. So hopefully we get that listing of where all the things are on the stack, and we can just sort of work out that if we write 40 bytes plus however much gets pushed before we change RSP, in this case, one 8-byte value. So if we write 48 bytes, then the next 8 bytes will overwrite the return pointer. That's how I tend to calculate the amount of overflow that we need, but using GDB is also fine. So let's see. So we can see that the offset between the start of our input and the return address is this address minus that address equals 48 hex, which will be 18 integers with the 4-byte D-word integers. Now for what to execute when we get the return address. Since the binary is statically linked and there is no PIE, we can just build a ROP chain using the binary for gadgets, and we without an info leak. Okay, so maybe before I go on, maybe what I am misunderstanding about PIE being off is that, like, actually you don't even get the stack at a random address. So maybe if they know the stack address, then they just write it into the stack and calculate that address and put that into the thing that gets popped into RDI. That also seems doable. Okay. The ROP chain will essentially just make an exec VE syscall to /bin/sh. There are 4 registers that we need to control in order to make this syscall. Check out this blog about Linux system call table for more details. So we need racks to be 3B hex, which is the exec's VE syscall number. We need RDI to be a pointer to /bin/sh. We can put null for RSI for no arguments, null for RDX for no environment variables. Okay, that's what we did. To do this, we will need gadgets to control those 4 registers. I typically like to go with gadgets like pop RAX ret, since it makes it simple. We'll also need a gadget to write the string /bin/sh somewhere in memory that we know. Let's find our gadgets using ROP gadget. Okay. So maybe they're not putting it on the stack. So they use the ROP gadget, same library that we did. And they are grepping for pop RX ret. I guess they're doing a full, like, I was just searching for one, single instruction or even portions of an instruction and then sorting through to find out which ones are what I need. But this seems like, especially now that I know that the pop ones are probably common enough that we could find any of them, then I could probably just do a quick search for that kind of thing and expect pop RX /ret is going to be in there somewhere. So they have pop racks, pop RDI, pop RSI, pop RDX. Okay, yep, we ended up using all of those. So we can see the gadgets for controlling the 4 registers at these 4 addresses. Now we need a gadget that will write an 8-byte value to a memory region. For this, I would like to start my search by searching through gadgets with move in them. Okay, and then after looking through that results, we find this gadget which does move RDX to the address at RAX. Okay. This gadget will move 4-byte value from RDX to whatever memory is pointed to by RAX. This is exactly what we need and a bit convenient since we already have the gadgets for those 2 registers, and this gadget doesn't do anything else that we need to worry about. The last gadget we need will be a syscall gadget. We found the same one that we did actually. That memory address is familiar. Okay, so they're doing something that I probably should have occurred to me while I was working on this. Since we have writable memory in general, we can just pick an address in a writable memory segment, pop that address into the register, and then find a gadget that writes a different register into that address. So that's really a much more straightforward, like, rather than, we have to write it on the stack, or I have to find something in the binary that writes it to these known memory addresses. Like, we just since we don't have ASLR on, we can figure out an address that's writable and put stuff there. That's, a smart way to go about it. Another way, maybe, even if you had ASLR, you could do a slightly longer ROP chain and call like a mmap syscall and pass in the right info so that it allocates you a new memory segment, and just make it 1 page or whatever, and make it a writable, readable memory permissions, and then wherever it stores the result of that, whatever address comes back from the mmap syscall, you can use that in a register and do what you need with it. So yeah, maybe I'll try that on another one. As just like, can I, if there's ASLR on, and I don't need access to this or that, like, I don't want to return to libc kind of thing, like return to a call to system or something. Can I just write enough gadgets to do an mmap syscall and then write gadgets to write a string into that location, which I have just allocated, and then write the syscall for execve? I don't know. Seems doable, but it's also the sort of thing where once I start actually trying to do it, maybe I'll find out that there's some obvious, not obvious to me right now, but obvious when I get there kind of reason why it doesn't work. Seems worth trying though. Okay, continuing on. This gadget will move 4 bytes, move the 4 byte value from RDX to whatever memory is pointed to by RX. This is exactly what we need. Oh, we did that one already. Okay. And then they get the syscall. So there are 2 more things we need to figure out. The first is where in memory we will write the string /bin/sh. Let's check the memory mappings while the binary is running. Sure. You've got the heap here. Seems like a decent place to put it. You've got your data segment from the binary, I think. I guess this is the data segment from the binary. But that's also read-write. And then, I don't know, maybe why this got allocated, I don't know. It's not associated with any particular location, so it was just like an mmap call at runtime. But all of those are doable. The stack is presumably random. So these 2 might be random just because of ASLR on the system, but this one at least is probably going to be a fixed address because the binary is not PIE, so it can't be written to a random, like it can't be based at a random location. Okay, we see that the memory that begins at 0x6c0000, yeah, so that's that second one. Okay. Looks like a good candidate. The permissions allow us to read and write to it. In addition to that, it is mapped from the binary, and since there is no PIE, the address will be the same every time. No info leak is needed. Yep, same logic. Okay, cool. Looking a bit through the memory, 0xc1000 looks like it's empty, so we should be able to write to it without messing up anything. Although we could be wrong with that. I also don't think that you need to worry about like clobbering some existing data because you're about to do a syscall to run a shell. I think it's usually perfectly fine to say the binary continuing to work afterwards is forfeit, especially as you are overriding the ret from main. So like whatever else is going to happen, it's still quitting out of the program. There could be some cleanup add exit functions or something to close file handles and all that, but I don't know. I'm not too surprised if my exploit doesn't result in the program that I'm exploiting actually shutting down properly. So just write it wherever you want in there. The second thing we need to worry about details with are about details with what we are overflowing on the stack. Okay. We see that between vulnbuff and the bottom of the stack, where the return address resides, is the pointer to calculations. This will get overwritten as part of the overflow. This is a problem since the address is freed prior to our code being executed. Yep, I mentioned this earlier. However, looking at the source code for free tells us something extremely helpful in this instance. I found it here. I don't know, let's look at this page. You could probably just look in the man page for free. Where am I looking? Have free in here? Yeah. It's free just at the end. Yeah. So the alias for libc free. Okay. I guess this is glibc. So, right. Free on 0 has no effect. Yeah. And I'm, that's probably written into the man page for free because I think that's just part of the standard, the C, whatever standard. I mean, maybe it wasn't the case before a certain version of the standard, but I think we probably don't need to look at the source code for that. And if we're looking at the glibc source code, I would not use this website. I don't know what this website is, honestly. I guess that's nice. It probably looks better when I turn off the dark mode. Oh, that is actually kind of handy. So as long as this page is regularly updated, it's not a bad place to go. You can certainly find the source code of the glibc project on the GNU website. They've got a Git web hosted thing or whatever, and you can browse around and search through stuff. And that's how I've traditionally been able to find details that I need from glibc. But that website seems nice just because I think you can just click on a name and it will find the name. So it's a lot like the kernel source explorer website, which I think it's elixir .bootlin. Yeah, this is another good website, elixir.bootlin.com. If you ever want to look at kernel source, you can go in through stuff and find, I don't know, let's open this one up, and all the references to other files, all the names of stuff are links to a search for that name, so I can see all the files where we actually call that function and stuff. Very handy. Obviously you can get that kind of thing in your IDE if you have it set up properly, but if you aren't, if you don't have the kernel source code downloaded to your computer, just doing it through the web is probably an easier way to go about it. Just while you are, what am I saying? If you're not browsing through that code all the time, it's probably just simpler to do it on the web, on the occasions that you need to look at it. Okay, so, right, they identify the thing that I saw, which is if mem is equal to 0, then we just return. We can see here that if the argument we pass to free is a null pointer, then it just returns. Since the function writing the data for the overflow is memcopy, we can write null bytes. So if we just fill up the space between the start of our input and the return address with null bytes, we will be fine. With that, we have everything we need to make the exploit. In the comments, you can find the exact ROP chain I used as well as what each part does. Also, I wrote some helper functions which will write the values I want using addition. Yeah, oh, so they did a pretty similar, kind of thing with an interesting, why do they, I guess that's for adding a 4-byte. Yeah, okay. See, I don't think that you need to do the mask and then shift, but in any event, they came up with some code that is pretty similar to what I was looking for. They did theirs a little bit smarter in terms of naming the gadgets, so that when they write this stuff to say add that gadget, add this value, etc., they just get it directly. That's definitely smarter. Okay, and then I don't know why they didn't run into a similar issue. I mean, maybe it's different on a Python 2 or something, but let's say this is the value for pop RAX, which is the first thing they're adding. Then they get the lower D word here, and they get the higher D word here. But if this higher D word is 0, right, then that's going to be 0 shifted 32, still 0. And so they're going to send negative 100 as the string, I would think. I don't know. I could just be misunderstanding there. In any event, it does seem, like a pretty similar approach to what I arrived at. And they do just 9 calls, right? Because they do 2 separate calculations per time they call add. So that ends up being 18. Okay. And then they run it, and they get the shell. Okay. So I think I was pretty darn close to what was intended for this. I now know a nice trick that I, probably could have, I had all the knowledge to be able to understand it, but it didn't occur to me for whatever reason, of just write to a memory address that you do know, and then pop, and then move into, move that address, or write that address onto the stack and pop that into a register. So I will have to use that in future scenarios, especially where I don't have ASLR or a PIE executable preventing me from knowing where any of the memory segments are at. Yeah. That is, I think that's everything I'm going to do in this stream. Hopefully, when we get to the challenges following this, they won't take quite so long. I don't know whether I'm going to try to use ROP on everything going forward. Hopefully it won't be required, just for the purposes of not taking a long time. But I don't know if it is required on everything, and then I do it every single time. Maybe I'll just get better at it to the point where it's actually not going to take me multiple hours to get a single one correct. That would be ideal, I guess. And if it starts looking like everything from here on out is going to assume I need to use ROP, I think the format string stuff probably won't. But I don't know. I mean, all of these are just different ways that we might be able to write data somewhere, and some of them might be writing data in a way where we aren't getting a shell directly, but we're writing to the PLT to cause a function to call system instead. I don't know. So there might be some scenarios where we aren't using ROP, but it wouldn't be surprising if all the ones that involve doing a buffer overflow on the stack from now on require using ROP, because I don't know, we've already done a bunch that didn't, and they do seem to be getting more difficult. But at the same time, there is just a whole section called ROP where we go through a bunch of different versions of it, or different varieties of how to do it. So we'll see. Oh, ROP Emporium is literally one of the the entries. So yeah, I guess why is that under ret2? Okay, it's just there are multiple versions of ret2 CSU, I guess, and one of them is from ROP Emporium. So at the very least, by the time we get to this one, I think I'll try to go through the others, the previous ones in the ROP Emporium website, because if I'm trying to get decent at binary exploitation, developing exploits for vulnerabilities, if I'm doing vulnerability research and I want to make POCs or something, it sure seems like ROP is going to be the bread and butter for that, just because if you're compiling a binary and aren't putting on the NX bit in 2020, you maybe shouldn't be compiling binaries that other people are allowed to run. There's got to be standards at some point. So that just means we have to heighten our skills, and I'll just have to keep hammering on the ROP stuff. So okay, next time I come back to this, I will be working on the DEF CON Qualifiers 2016 challenge called Feed Me. DEF CON Qualifiers, I did a little bit with it in 2019, and by a little bit I mean I did the one that was labeled intro, and that took me a while and was interesting, and I learned a lot from it, but I don't think I was in a position to do anything beyond that one. So being able to do anything from the quals that was not like the very introductory entry is going to feel good, I guess. And the speedrun stuff especially was pretty neat from last year. I didn't do any of them, even though they were probably more targeted at my skill level. Granted, they were intended for, like, in terms of getting points in the CTF, you'd have to do them in maybe like half an hour or something. So for the people that know what they're doing, they were super easy. But for my skill level, doing one in an hour or something would be a much more reasonable goal. So we'll get to the Feed Me one, and then we'll try the speedrun one after that. I don't know when I'm going to stream next. I would like to stream again tomorrow and sort of get back into the rhythm of it, but I did miss a couple days since my previous stream, so I don't want to just promise anything, because I don't think my schedule is so regular that I can promise. But it is the weekend again tomorrow, so we'll see. All right, thank you to everybody that was watching. Thank you to whoever is currently watching. I see one person on the viewer list, so thank you for sticking out this whole time. And I guess I can end with giving out my contact details. If you go to hamled.dev, hamled.dev, that is my website. There's not actually a website there right now. It's simply going to redirect you to my GitHub page, which is also hamled. And it has my email address on there if you want to send me an email, if that's how you'd like to reach out to me. And otherwise, you can reach out to me on Twitter, twitter.com/hamled, again, HAMLED, online. And mostly I tweet about political stuff. Yeah, but, I follow a lot of people that do interesting technical stuff, and I'm happy to follow you on Twitter as well. Or if you just want to tweet at me, like, feel free. Always happy to have a conversation, hear your feedback, positive or negative, honestly. So yeah, that's all that I've got for today. Thanks again for watching.